Soni Kumari. I am assistant professor in ABES Engineering College, Ghaziabad. The today's session will be about KNN algorithm, part 2. I have already discussed KNN algorithm, part 1. There I have discussed about the basic concepts of the KNN algorithm. For the better understanding, you need to go through the first part, and after that you need to see this. So the agenda of the session will be, we will discuss the KNN algorithm with the example. So here you can see the examples of the data set. Like here we have brightness, saturation, and this is the class. So depending on the combination of brightness and saturation, there will be the class of colors that will be either red or blue. So we will apply here KNN algorithm to get the prediction of any new data, whether it will be of red color or it will be of blue color. So the KNN algorithm will help to find us for any given data combination of brightness and saturation. We will be able to determine whether it is red color or blue color. So as I discussed in the part 1, the steps of KNN algorithm, the first step was that we assign the value of k. So here you can see that we have taken the value of k as 5. We have assigned the value of k as a 5. What is k? K is the number of nearest neighbor. Now, the second step in KNN algorithm was to calculate the distance between the given data points and the available data points. Please mark my words that I am saying that the second step is to calculate the distance between the given data set and actual data set. Here you can see we will use the Euclidean distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. Here square is missing. And this is our given data set. Like brightness is 20 and saturation is 35. Now we have to predict what will be the class of this combination, whether it will be red or blue. Now we will find the distance for each data, for each given data. For example, the first given data is 40, second is 20, the brightness is 40, saturation is 20, and the data for which we need to predict the value is brightness is 20, saturation is 35, that is given data, and we need to predict whether this combination will belong to the red class or blue class. And here we have available data, and this is, you can say, observed data or query data. Now, how you calculate the distance? We will calculate the distance for each given data. For 40, this one, for this row, for this row, for this row, for this row, for this row. Similarly, we will calculate the Euclidean distance for all these rows. So first, I have calculated the distance for this first row. Now, how we calculated? The given data was, brightness was 20 and available data is 40. So x2 minus x1. The given data for saturation was 35. And for the first row, it is 20. So 35 minus 20. And you will calculate. And finally, you will get 25. Okay. So we have calculated the distance for the first row, that is 25. Now, similarly, we will calculate the distance for second row. That is this one. As the brightness was given 20 and saturation was 35, that I have already mentioned earlier. And here available data for second row is 50 for brightness. So 20 minus 50 plus 35 minus 50. And we have calculated the distance, that is 33.54. Similarly, with the help of Euclidean distance, we will calculate the distance for each and every row. Okay. Now we have calculated the distance for each row. You can see here. The third step was that after calculating the distance between the given points and the available points, what we need to do? We need to arrange them in ascending order. Okay. So we will arrange them in ascending order. So we have arranged the data in ascending order. You can say C 10, 25, 33.54, 45, 47. We have arranged all the given, all the available data in ascending order. And remember that we have taken the value of K equals to 5. Okay. So what is this? K equals to 5. Here the K is number of nearest neighbor. So we will take 5 nearest neighbor. And how many data we have? 1, 2, 3, 4, 5, 6, 7. And as we have assigned the value of K equals to 5, we will take only 5 values. So we are going to take this value 10, 25, 33, 45, 47. We have 5 values now. Now, here you can see that we have taken only 5 values, as I already told you. And why we have choose 5 values? Because we have assigned the K as 5. Now, the final step was that we take the majority class. Now, you can see in the given table that the nearest point will be 10, 25, and 33. These are the nearest points. So what are the majorities? How many reds are there? How many reds are there? You can see here we have 3 reds. Here we have 3 reds and 2 blue. That means majority of, like you can find here, 3 red, 1, 2, 3. So there are 3 reds and blue. We have 2 blue. So you can see here we have 2 blue. So as you can see, the majority is red. So the final value for the given data from which we started will be red. So we have predicted that the combination of the given data was red. So we have predicted that it belongs to the red class. So new entry is classified as the red. These are the references you can go through for more information.